Good afternoon, I'm Miss Shram, and we are talking all about magnetism. So at the end of my part, you'll be able to explore interactions between magnets and various materials. So today we've got two questions to focus on with magnets. So how do magnets interact with other objects, and how do magnets interact with one another? So we're going to explore both of those things, and we're going to use magnets looking like this. So these are magnets you might see in your classroom, and they're ones that we are going to use here in the lab today. Okay, so I've gathered all these materials, and I found these in my science lab, but they are also things that you probably have in your classroom or at your house. So if you want to explore with magnets later on your own or with your teacher, these are the things that we're going to be using today. So, all right, I'm going to share my little table with you. And I have these fancy dancy little bar magnets. And that's what we're going to use mostly today. And then I'm going to bring out each object one by one. So I'm going to put the object in the middle. First, we got this little wood cookie. And then I'm going to bring the magnet near. So I want you all to be thinking while I do that, do you think that there's going to be an interaction with the magnet? So do you think this is going to be magnetic? Yes or no? So magnetic or non-magnetic? So let's see, first one. Well, it didn't move, nothing happened. So that is non-magnetic. All right, so wood is not magnetic. How about a paper clip? So I'm going to set my paper clip there and then bring my magnet close. Whoop. And as you can see, the magnet picked up that paper clip. So that tells me that the paper clip is magnetic. All right, so we got one yes and one no. Next, I have a marble. And I'm actually just going to put the marble in a plastic tray because otherwise this glass marble is going to roll right off the table. So I'm going to bring my magnet near. Nope, nothing happened. So the glass marble is not magnetic. Let's see. I have a crayon. No movement, not magnetic. How about a pipe cleaner? I love using pipe cleaners with my crafts. So let's see, they've got a wire in it so it can keep its shape. Let's see if that's going to be magnetic. Haha, it is. So our pipe cleaner is magnetic. All right, let's see what I have next. I have a soda can. And soda cans are made out of aluminum. Not magnetic. Okay. Let's see. I've got a little ring magnet, like you might find on the back of a refrigerator magnet. So let's see. Haha, it is magnetic. Okay. And I got two more. So I have a compass here. And I want you to focus on the red part of the arrow. So there's a little dial in the middle, and half of it is red. So when I bring my magnet close, I want you to pay attention to that red part of the arrow. So let me see. I'm bringing my magnet near, and it's able to make the arrow move and turn without even touching it. So let's see, if I flip it around, the arrow flips around. Interesting. So the compass is magnetic. And then my last thing is iron filings. So someone took some of the metal iron and shaved tiny little bits off. So it's kind of like little particles, almost like glitter, but it's all made of iron. So let's see what happens when I move my magnet underneath. So I put it in a petri dish just so I don't make a mess, because otherwise this stuff will get all over the place. So I'm going to put my magnet underneath. So I'm able to move the iron by using my magnet. So iron filings are magnetic. Let's review our findings and see if we can draw any conclusions from them. So the objects that were not magnetic were the glass marble, the wood cookie, the crayons, the aluminum soda can, and the rock. Then the items that were magnetic were the pipe cleaner, the compass, the paper clip, iron filings, and the ring magnet. So I won't be able to hear your response, but I want you to tell a friend next to you, why do you think that those items that were magnetic were attracted to the magnet? So what do they have in common that makes them magnetic? All right, go tell your friend. I'll give you a few seconds. Okay, hopefully you noticed that all those items that are magnetic have metal. So they all have metal in them. But you might also have noticed, hello, Ms. Schramm, that aluminum soda can is metal too, but it wasn't magnetic. That is because only some metals attract magnets. So iron, nickel, and cobalt are the main ones. Those are the ones we'll talk about together. Those ones are easily magnetized. A few other metals as well, but aluminum is not in there, so I kind of tricked you a little bit, sorry. But the point is to let you know that not all metals are magnetic, but iron, nickel, and cobalt definitely are. Okay, so that answers our first question, how do magnets interact with other objects? Now we're gonna see how magnets interact with one another. So I have two little bar magnets like we've been using, and you may have noticed that they have a red side and a blue side. And now on your screen, you can see that the red side has an N and the blue side has an S. That is because there's a north and south pole to all magnets. Every single magnet has one. It's just that these that we use in our classrooms and science labs are easily color-coded so that we know when we're doing the experiments which side is which. So we are going to try to bring these magnets close together and see what kind of interaction they have. So when I bring north poles together, we're going to see then a north and a south pole, and then two south poles, and we'll see what happens. So let's get back to the science table and we'll see. So I have my first magnet facing this way. The north pole is facing in, and this one I'm going to bring closer until we see what happens. North poles, whoop, it pushes it away. It pushed it so much it turned it around. So two north poles together push apart. That means they repel. So if you were holding these two magnets in your hand, you would be able to feel that magnetic force between them repelling each other. They are pushing apart. All right, now I'm going to flip it around and bring the south pole to the north pole. So what do we think it's gonna happen? Do we think it's gonna pull together or push apart? Let's see. Whoop. It pulls it along. It almost snaps right together. And once again, if you're holding these magnets, you would feel the magnetic force pulling them together. You've got to put a little muscle to pull them apart. So the south pole and the north pole are attracted to each other. When they pull together, that's attract. Now, I'm going to put my south pole facing the south pole. And based on what happened previously, let's see, do you think they're going to attract or repel? All right, let's see. Boop. It repelled the other south side. So you could feel the south poles push apart. Whoa. All right. So let's review our findings and draw our conclusions. So when we put two north poles together, they repelled, right? They pushed apart. Then when we brought a south pole and a north pole together, they were attracted. Then when we brought two south poles together, they repelled again. So that tells me that when the poles are the same, it repels. And when they are the opposite, they attract. All right, let's check out the magnetic field really quick. So I mentioned the magnetic force. So I can feel the magnetic force, but I can't see it. I can't see them pushing apart. And I know they have a magnetic field around them, but it's hard to envision what it looks like. So what somebody did was they took a picture of one of these bar magnets like we've been using and those iron filings from before, and they sprinkled them on top. And then the magnet attracted those iron filings and it kind of made a pattern so that we could see what the magnetic field and those magnetic forces look like. So that's a little diagram to kind of show you how the magnet works and where that magnetic field is. So the magnetic field, all that is the area that's affected by the magnet. So the bigger the magnet, the bigger the magnetic field. These are rather small, so I had to bring my magnet pretty close to those objects before I got an interaction. If it was a stronger magnet, that distance would be like smaller. I would have to, or sorry, bigger. I wouldn't have to bring it so close. But either way, that is the magnetic field. So our vocabulary review is when magnets are opposite, they attract, they pull together. When the poles are the same, they repel or push apart. And magnets attract metal objects that contain iron, nickel, or cobalt. All right. So my challenge to you before I send you off is later in the day, or maybe when you get home, or sometime with your teacher, you can explore your classroom to find more examples of magnetic and non-magnetic objects. And if you don't have one of these, that's okay. You could just take a magnet from your fridge, or sometimes you have them on the whiteboard, and see what they stick to. All right. I hope you have a great rest of your field trip, and I can't wait to see you next time.